So today is actually the panel one of the Web 3.0 Tech Talk. So today's topic is what makes Web 3.0 trustworthy. So I'm the moderator, Bruce. I'm the co-founder of NKN. And so the Web 3.0 Tech Talk actually have a quite successful history. So we have been running this one 3 years in a row now. And in the first 2 years, we have the CTOs and tech leads and founders from many Web 3.0 projects, including IoTeX, IPFS, Blockchain, NKN, as well as Theta, and many other famous projects, and Bluezell, for example. So this year we're going to make it's a little bit more casual and informal format. So we'll have a panel of 4 CTOs or tech leads from the 4 different projects, and then discussing various topics, and also pick up questions from the audience and also from our Reddit. So that's kind of the format. So we'll break into roughly 3 segments. In the very beginning, after the introduction, we will have each of the panelists talk a little bit about themselves and also their project, how they address the trust issue for Web 3.0. So that's the first segment. The second segment will have a list of questions from the audience and collected before this panel, and we'll pick a few interesting ones to go for it. And then if time allow, we'll move to the third segment, which will be open the mic and also pick questions from the Twitter space. So those are the 3 segments for today, and let's get started. So first of all, I will start to the introduction of the panelists. So let's start with Raullen, please. Please say a few words about you. Let's try to keep it to about 3 minutes. So about yourself and also about IoTeX and how what you're working on address the trust issue for Web 3.0. Please,
yeah,
Raullen.
Thanks, Bruce. Yeah, thanks for having me, guys. So this is CEO, co-founder of IoTeX, Raullen. So we have been here for 4.5 years, definitely like starting back from 2017, very focused on the IoT and the blockchain, right? So in the past years, we have built up this like a layer 1 POS chain, EVM compatible, and have been launched in 2019, have a mini ecosystem of 200-ish projects already running on top of IoTeX, and also supported by all the top exchanges in the world. So that's kind of layer 1. So starting from last year, so we are actually shifting our focus a little bit away from layer 1 to actual layer 2. So that's where we want to do this kind of decentralized off-chain computing for a lot of real-world data. So this is related to the trust issue, like Bruce was talking about, right? So if you really think about how the human society actually gets organized, it's all because like endorsement from each other, right? So sort of like a web of trust model you have in the past. For example, if you a friend refer you another friend, so you will like trust this new friend. So this is something like we are thinking about. So that's why I have like a real world, some sort of like a credentials or trust or like endorsement from the real world to your digital identity, for example. So right, that is like a way to build up like trust to make Web3 more trusted. Yeah, so that's definitely like one of the things we're working on. Entirely, the things we're working on is called MachineFi, right? So try to connect it all the off-chain web, web to real world, data utility onto or into the Web3 space is definitely something like we are very passionate about in the future. So yeah, so that's about me. That's about what I'm working on.
Thank you, Raullen. That's excellent introduction about you and your project. So let's move on to our next panelist, Dietrich, please, from IPFS.
Hello, everybody. Happy Friday. Thanks for having me here. My name is Dietrich Ayala. I work on IPFS at Protocol Labs. I run the browsers and platforms team, and I'll tell you a little bit about what we do there.
Dietrich, you're on mute.
Oh, can you hear me now?
Yes, now you're good. It's just get on to, yeah, please.
Yeah, my name is Dietrich Ayala, and I work on IPFS at Protocol Labs. I run the browsers and platforms team, and I'll talk a little bit about what that team does in a moment. my mic keeps shutting itself off. I work on IPFS, which is the Interplanetary File System. And IPFS allows you to distribute content over peer-to-peer networks in a cryptographically verifiable way. It uses the essentially the contents itself. The contents itself has the address for that data. So it's a system that instead of HTTP, where you reference data by its location on a specific computer or set of computers, by the contents, the identity of the contents itself, which makes it so that you can trust that what you asked for is actually what you will get, and which means you no longer have to care where that comes from, which is a very unique property that is very different than the trust model of the HTTP web. Before joining Protocol Labs, I spent over a decade at Mozilla working on the Firefox web browser and a number of other projects there. So I come from Web 2, but have moved into working in Web 3 to be able to make the web more decentralized. And that's me.
Okay, thank you, Dietrich. You have been regular on this panel as well. So thank you to be here. And let's welcome Chi Zhou, the founder of Web3Q and QuarkChain, to say something about himself and what he's working on. Please, Chi.
Many thanks for the introduction. Hi, my name is Chi Zhou. I'm the founder of Web3 and QuarkChain. QuarkChain is a high-performance sharding multi-shard blockchain that employs the sharding technologies to increase the blockchain scalability. And these days, we are also working on a new project called Ether Storage, which we closely work with the Ethereum Foundation on the frontier problems of blockchain. That is one most important is the data availability problem. And we also we've built on top of data availability problem. We are working on the Ether storage that aims to scale the Ethereum storage dramatically with much lower cost and also much higher capacity. I'm also co-author a couple of the Ethereum improvement proposals, including EIP 4804, EIP 4972, and EIP 5018. And so I think one of the most interesting EIP is proposed EIP 4804, which defines a new scheme that is Web3, / as a replacement of current HTTP, so that we are able to render and browsing any web contents that are hosted by smart contracts on top of Ethereum. So Ethereum is right now is perhaps the largest decentralized trustworthy platform. So we believe that all this technology we built and that we can further bring a lot of new applications like trusted website hosting, like decentralized social network on top of the largest trustworthy platform. Yeah, thanks for everybody.
Thank you, Chi, for the introduction. So we have lots of questions about that as well, so we'll come to that later on. The last panelist is actually from NKN as well. He's the CTO and co-founder of NKN. So let's welcome Raullen Chai. Raullen, please.
Hello, my name is Raullen. I'm the CTO and co-founder of NKN. So NKN is basically a decentralized networking layer for Web3. So currently, when we talk about Web3, probably the first thing we think about is like the smart contract or those on-chain process, right? But that's not enough. So when we build a Web3 like application, a lot of times we need like the real-time communication between peer-to-peer. Like currently, we are using the Twitter Space, right? This is a peer-to-peer communication tool, and also sometimes we need like instant messenger, or we need access to the remote machine, or like chatting in an NFT application or whatever. All those requires real-time communication, which like existing Web3 cannot provide. So that's why we built NKN. So basically, in NKN, we moved from the Web2 like internet address, like IP address, to Web3 address, which is based on cryptography and public key. And also we moved from the client-server model, those server relay, to the pure decentralized relay, using the unused bandwidth of all those like tens of thousands of miners in the world. Currently, NKN network has like almost 100,000 nodes in the network. And we are already like the largest decentralized network in terms of number of nodes in the world. And we are still growing. Using the NKN, we can build any like real-time communication applications, like instant messenger, like the Twitter space we are doing, and yeah, all those more things. And we can talk about that later.
Okay, thank you, Elon. All right, so that's kind of basically our first part of the program. So we have an introduction from each of the panelists as well as their project related to trust. So we have quite a few questions from the general audience. So let's start with some simple ones because I think today most of people might not be researchers. So let's try to give a good technical explanation without getting into too much of the kind of obscure facts. So the first question is, how can Web3 protect my privacy? So we all know that blockchain are public data, and but how can those technology protect my privacy? So any panelists who want to jump in?
Yeah, maybe I can add my 2 cents here. So yeah, I would try to avoid some of the technical details. So I would say for most people, the most easy way to protect your privacy using blockchain is to basically decouple your identity with some of the financial activities you do with other people. So currently, before the blockchain system, if you want to make financial transactions, like send other people money or something, you have to use tools like PayPal or like let's say maybe a Chase QuickPay or something. All those are kind of bound to your real world identity, and there is no way to hide that, right? Even some of those data may not be like open to the whole world, but at least the service provider knows exactly who you are, who you make transaction with, all those kind of things. Because when you make money, you cannot avoid those financial institutes. But for you, the easiest way to use blockchain is probably get some tokens and send it to other people, right? But in the blockchain world, identity is not binding to your real world identity. Although you might need some financial institute to move your fiat to your cryptocurrency, but after that, everything stays in the cryptocurrency world, and identity is based on like public key, those cryptography instead of your real world identity. And by doing that, you can pretty fair stay as a symbol, as a public key behind that identity, and do not reveal your real world information. That's the probably easiest way to protect your privacy in the blockchain, and it probably can be used by anyone.
Okay, that sounds interesting. So this kind of anonymity and privacy is really kind of built into some of the system we are building today. So that's good to hear. And I think I remember Dietrich also talked about the kind of replacing HTTP model with this new model, and also Chi and also Dietrich. So one question about this kind of content, like nowadays, let's say we trust Wikipedia or let's say New York Times to provide us information, or we store our information there. But how can a Web 3.0 world that we can trust something that we don't know what that thing is to store our data and make it preserved for the future, but also kind of so also have the kind of privacy factor and the trustworthiness there. So do you, Dietrich or Chi, want to talk a little bit about the content and the storage part?
I can talk a little bit about the privacy aspect of how we think about that on IPFS network. And with IPFS, it is a public network by default. So it's a very different privacy model than in that communication often goes through a third party. That third party is the website operator often. Maybe that's Facebook or Instagram, or maybe even some smaller site that you use. However, with IPFS applications, you can connect more easily directly between individuals or through a cooperative network, sometimes anchored to a block. sometimes not anchored to a blockchain, but just through the P2P network itself. So one of the things that we focus on from a privacy aspect is if you are putting data out of the public network, is to make sure that that data is encrypted first using your PKI the way that we just heard. The other way to do it is through direct private networks. So when you can make a direct connection to another peer on the peer-to-peer network using a private connection that is direct. So it's basically a transient private network between multiple parties without a third-party intermediary the way that you have on a regular Web 2 website. So it's a very different approach to thinking about privacy. And it also requires a little bit more care in how you interact with other parties on that network, but also does remove the trust websites by default type of model of privacy, where you don't really know what's happening on the other end of an HTTP connection in the regular web today. So it's a very different model about thinking what private interactions mean and what private data means. And in a really hybrid environment of both party to party and then also multi-party communication on public networks. I think different topic altogether from that privacy aspect, which is that right now the trust model of the regular web is really rooted in the intersection of SSL and DNS, where you have a domain name that is encoded into a certificate, and browser vendors that say, okay, SSL connection to that is registered all the way up through a root certificate, you can trust that website. This is really problematic because one of the biggest jobs that Google has is it runs a untrusted websites list. Just because something is encrypted between you and the HTTP endpoint doesn't mean that you can actually trust the organization on the other end. This means that we have a real problem with trust on the web today, and we have to come up with new approaches to understand how to trust what we have when we can't trust the information as well. I think you alluded to another different aspect of that, which I think is interesting, and I'll let Chi speak to, which is about how we reference and store that data to be able to make sure that it's available. And that's maybe another dimension of trust. How can we trust that the data we had yesterday will be available to us tomorrow?
Thank you, Dietrich. So Chi, do you want to expand a little bit of what you talk about the EIP 4804, or that relate to how you want to change the way you access information instead of the HTTP?
Yeah. I think Dietrich just gave a very good examples of how right now how we trust Web 2 and how it was broken. So, for example, for DNS, it's kind of centralized. So, which means that so first it can be censored. For example, there are a couple of websites that was seized by U.S. government because they said that this website basically hosting some illegal information, and also, for example, reason tornado cache is kind of another like censorship-resistant problem that nobody right now is able to directly access tornado cache. And for DNS, it can also be contaminated. For example, recently, Cellular Network was attacked by DNS hijacking. So when user type the website, they have no idea whether the website is, for example, the actual website that is from for example, the project, the host itself, or the website itself can be attacked. For example, their server was attacked. This key was leaked, so that they are able to replace the website with some kind of the address from the hackers. So there's something that we want to address, and the EIP 4804 is one of the target that we are going to. The target is going to replace a centralized resource that is defined in HTTP with we call decentralized resource that is defined by a smart contract that runs by any EVM compatible chain, especially Ethereum. So Ethereum right now is perhaps the largest trustless platform, and it also aims to be going to be the minimize the trusted platform in the future with a couple of technologies. including data availability and also stateless client. So EIP 404, with EIP 404, we are able to, for example, browser those websites, those what we call trusted website, hosted by smart contracts, so that we are able to exactly know that those websites and corresponding ENS names are the content that is from the blockchain, and nobody is able to change the content of the website secretly. And one good thing is that since the website is hosted by smart contracts, and then so that we are able to dynamically change the content of the website using the capability of the smart contracts. For example, we can easily enable decentralized social network like Twitter, all these things, by putting all the data from the users and put them together and display on top of the front end. So this is something that can be everybody is able to verify all the, for example, all the articles, all the comments, all the content from the website is verified and is trustworthy by the blockchain cryptographic proofs. Yeah, so this is something that we are currently building, and together with the data availability technologies, which further prevents the data withholding attacks. That's something that so the data providers may, for example, waste kind of like censorship attack, that they stop running some data from, so that the receiver cannot, even they know where the resources is, but they cannot be able to retrieve it. So data availability developed by Ethereum is the key issue to address, is to prevent if a malicious attacker withhold a large amount of data, but the network still able to recover it using kind of advanced resettlement code. Also, one of our targets is besides to solving the short-term data availability problem that Ethereum is addressing, there's also a long-term data availability problem, that how we are able to make sure all the data, when after uploading to the Ethereum, future Ethereum, still the users can still access those data in the long term, maybe 1 year, 2 year, without worry about the trust issue, like for example, withholding attack, and also temper attack. Yeah, that's what we are currently doing.
Oh, thank you. Thank you, Chi, for the explanation. And that actually kind of remind me of something else as well. So we talk about the kind of human-generated data for now, but I think there's also like even more machine-generated data. So I guess, Raullen, you are both kind of active in kind of MachineFi, but also in the DeFi as well. So can you talk a little bit about how can we kind of build the trust into kind of machine-based economy?
Hey, sure, Bruce. I think definitely I want to talk about maybe the paradigm shift about the trust, right? So in the Web2 space, if you think about it, we all trust Google, we all trust Twitter, we all trust Facebook. So that's why it's the least friction way for users to just put their data there. For example, you use Gmail every day, right? You use Uber every day. You use, Google Map every day. So because you trust this company, will not do things evil. So that's basically what user wants, some just frictionless, experience interacting with the virtual world. So in Web3, I think the trust model here is really different. So assume like a Google does not exist, maybe 5 years from now, or like, Twitter is dying, about 10 years from now, you have no such a kind of centralized party you can put trust upon. Then how do you trust, Ethereum? How do you trust, like all the crypto networks, right? So that is a very, very interesting question. I think that question is actually coming from a lot of trust for those crypto networks is actually coming from transparency. So you will have to, I'm sure like you guys know this as well, right? So as a founder for a crypto project, I think the most important thing for you to do is trying to make your network as transparent as possible. So that's how like different parties can get involved into your network. Take a look at here. For example, if this guy is a tech guy, he can take a look at the, kind of tech aspect of the network. And if another guy is coming from security background or maybe economic background, he can take a look at it from security or economics background, so on and so forth, right? So then everybody's contribute a little bit thing here, try to make the entire network trustworthy. For example, Ethereum is such an example. Everything on Ethereum is super transparent. So that's IoTeX, of course, and NKN and IPFS and everybody here. So people can actually put trust upon. So this is a very interesting kind of like a paradigm shift from Web 2 in terms of like minimize the trust here. Same for MachineFi or like a machine data, whatever data. So if we want people to trust what we're doing, we have to make like the results as well as a process as transparent as possible. Then it's easy for academic researchers, security researchers, hackers even, to take a look at this one. It's interesting, like I mentioned about hackers. I think of course, everybody like especially as a project founder, you don't like hackers, but hackers definitely have their kind of own plane in the Web3 space, because they are the guys who's trying to eliminate the things that's not secure enough, that's not long lasting from the entire industry, right? Trying to filtering out like the good ones so they can evolve as time goes by. So this is another interesting topic. Yeah, but definitely like as I'm thinking, I think trust and transparency is the most, it's kind of cornerstone for trust in Web3.
Okay, thanks, Raullen. Yes, I think we touched upon a few things, right, in your talk about the security. So one is kind of the model change, the paradigm change, and then Chi and Dietrich had talked about how can we secure the front end, like the websites and stuff like that, to be more authenticated, not just by trusting some central authority, but by smart contracts and maybe cryptography. But there's one more thing. So in recent years, and most of the kind of attacks or the hacks are happening on those bridges and cross-chain security, cross-chain solutions. So if this actually kind of those bridges and cross-chain kind of entities become the DeFi's kind of Achilles heel. So are there any ways we can kind of improve the security and trust for those? I don't know if we should call them centralized or decentralized, because the bridges and cross-chain functionality quite often are somewhere in between, a hybrid. So if anybody want to pick up this topic, and how can we secure the bridges and the cross-chain functionalities?
I don't know if it's quite the same, but it is somewhat similar, the situation that we have with IPFS gateways for HTTP. Like the same way that not everybody runs a full blockchain node or client in order to access distributed applications and dApps. A lot of people access data on IPFS through HTTP gateways to the network. And there's some challenges in there in similar ways to cross-chain applications and bridges, in that it is a point where you move from the trustlessness that Raullen was just talking about, where we have cryptographic validation instead of having to delegate trust to a third party. Here you are delegating trust to that HTTP server, hoping that it is not tracking your movements or your location or the content that you're serving, things like that, until we get IPFS actually implemented out all the way at the edge, all the way into the clients, natively in the browser. And I think that this type of situation will continue to be a transitional period with non-zero risk involved whenever you have to delegate some trust that way. And it seems like the cross-chain bridge situations that we've had, especially this year, often involve some area where there may have been transparency, but there wasn't full accountability or auditability or full visibility into what the relative risks were. One challenge when using, groups of people that are using technology that they're very enthusiastic about is that, their risk calculus is very different. And this can be a barrier also to adoption. Every time one of these bridge situations occurs, it is a blow to user trust in the systems that we're building. So it really is important to take that type of risk seriously. The way that we're approaching that from the IPFS world is really to push out IPFS and verifiable gateways all the way out to the edges, working directly on integrations in Chromium and Gecko and other browser rendering engines to be able to make sure that capability is pushed out all the way to the end user when possible. But of course, with really large distributed networks where the client you maybe need to have some or all of a portion of chain content. It makes it a different type of challenge for sure.
Thanks, Dietrich. Anybody else want to add to this?
So I have a couple of thoughts regarding the cross-chain bridge attacks. So a couple of attacks, as we have heard, like wormhole and also Ronnie, and recently Harmony were attacked. Basically, there are a couple of issues there. One issue is that a lot of bridge they basically introduce additional third-party trust. For example, Ronnie is basically operated by the bridge is operated by additional, I think, 5 or 6 cosigners. And since a couple of them private keys are stolen, so the attacker performed just a kind of like a steal order found just in a couple of minutes, and so that order create a lot of loss. And I think this is becoming more and more serious problem because we believe there's a lot of more and more like cross-chain activities, and there will be a lot of amount of money that put into the bridges. But the thing is like introducing kind of third party, especially this additional third party, will have any additional third party will create a new trust issue. So I think there are a couple ways that we will envision the solution of problem. One way is probably we can employ some kind of like light client technologies, but building on kind of like the ZK SNARK or ZKP, so that we are able to dramatically reduce the cost of the basically verifying an event happen on another blockchain without basically running an actual, I would say all the data, a full client, light client that basically transfer all the headers, like for example for Ethereum to another blockchain. So we just need to basically have some ZK proof that can quickly. It will take some time to prove, but you can be quickly verified on any target blockchain as long as it supports smart contracts. So this is one trend that I see. There's a couple of projects, research projects, and they are working to solve this problem. So I'm pretty, I would say, optimistic in this direction. Second direction is that even we solve the third-party issue, additional third-party issue in the bridge. Actually, the bridge will still need 2 minimum trust. That is the source of destination chain. So we still need to trust the operators of the source of destination. And sometimes the problem can happen if one of the chain, the trust of one of the chain, like source destination, is broken. For example, wormhole is a good example that for the source chain, that is Solana to Ethereum, the Solana, they used kind of like a deprecated API, which breaks the trust model on the Solana chain. So which Solana deprecated, but the wormhole contract did not upgrade and use the new API. So which the old APIs have some attack vector. So in such cases, we probably need to employ some of the other technology, like for example, on-chain rate limiting contracts, so that we are able to employ kind of like widely used technology in the centralized world, which basically when there's a large irregular, for example, withdrawal event happen on, for example, Ethereum, because Ethereum right now is probably the last target assets because of this decentralization and censorship resistance. So then we are able to put some circuit breaker to do more examination, so that if we respond quickly, then we can mitigate the cost to from the original TVL to a small amount that we set. The rate limiting we set, for example, maybe 10 million in one day, so that even we still the attack may still happen, but we can mitigate this, and so that we can learn lesson and try to how to improve. So there are a couple of things that I think we can practice in the future to further reduce the attack problem. And yeah.
Thank you, Chi. So actually, Chi actually touched upon the topic that some of the audience are asking about. It's about zero knowledge proof. So it has been kind of a very popular word, or ZK in short. So I think very popular word. I also myself have a question. So the zero knowledge proof not only kind of improve the efficiency of the cross chain, like Chi told us, can it also kind of improve trust at the same time preserving privacy? Because my limited understanding is if you have zero knowledge proof, you can have some of the financial transaction or some of the kind of computation that does not have to be public, but then you can still provide the proof and that's verifiable. So I don't know if anyone wants to take this question about how the zero knowledge proof can actually help with trust, and maybe also if it will help privacy as well. Because in the blockchain, lots of people understood that, okay, the code are public and all the transaction data like on the blockchain are public, but how can we preserve some of the privacy, especially like in terms of the financial transaction stuff like that? Can that help?
Yeah, I can talk a little bit more about it. So yeah, definitely I would say. So their knowledge proof can help the blockchain. Well, I would say actually their knowledge proof is more fundamental than that. So basically, the blockchain is built upon it. So zero knowledge proof might sound like a fancy word, but it's if you think about the digital signature, it is a zero knowledge proof. It actually proves that you like control that private key of the public key without revealing that private key itself, right? It shows that you own it without leaking much information. So that is a digital signature is a zero knowledge proof, and we know that the blockchain is basically built upon it. So it is actually already a basic building block of every blockchain system, and zero knowledge proof can do much more than that. Basically, as Bruce has mentioned, there are basically two ways that ZKP can benefit the existing blockchain like infrastructure. So one thing is, as you mentioned, it makes things much more efficient, right? It can compress some of the huge proof to a pretty tiny one and preserve reduce a lot of on-chain space, which is pretty expensive and precious. And the second thing you mentioned is that, it can actually do some of the proof, show some of the information without reveal the information itself. Because as we know, blockchain, all the information on blockchain is public. So some of the applications don't want that property, right? They want the data to be private. They want let's say as an example, sometimes some of them might want to find the intersection between two financial data without actually revealing the data itself, right? So that is a pretty common issue or problem that people are facing, and without zero knowledge proof, they probably have to reveal that data, and which is not acceptable in some of the financial institute. But with zero knowledge proof, they can actually do that they can show, okay, this two data set has some common elements, and they can just reveal the elements itself without revealing the whole data set. And that actually works well with blockchain. They can use the public blockchain as a platform to show maybe to probably put some of the public data or put some of the smart logic in smart contract, and while keeping the data itself as a private. So that would extend what the blockchain can do, not only from the public data set to actually the private data set.
Okay, thank you. Anybody else? Oh, Raullen, please.
Sure. For ZK, I have a different opinion, right? So my background is cryptography, so different. I have understanding about those things. So ZK is super cool. Everybody's talking about it, but I have a very different opinion because a ZK in its heart is super complicated, right? So it really depends on how you construct the circuits, which is not something like a normal people can understand. If you think about DeFi, why DeFi is popular? Because it's just like a average level engineer, so they can read into the smart contract and understand how it works and even try to identify bugs. But for zk, like it's completely different. I think there's only maybe less than 100 people in this world really understands how these circuits gets constructed, for complicated business logics and how everything works out. That means, so for some very fancy type of zk system, for example, my team is looking into zk EVM. There could be a potential bug and a really big bug, but no one really knows, right? Could even be a trapdoor. What does trapdoor mean? Trapdoor means like the designer just intentionally like putting some sort of backdoor here, so he can maybe steal the funds in the future if he wants. So that definitely goes against like this transparency I was talking about. Of course, you can trust on Vitalik, you can trust all those genius, saying like because this is a zk EVM or zk token technology they endorse, so it's security enough for everybody to use. But you cannot verify it as a normal people, right? That's kind of like things I was worrying about, Yeah, so that's my point.
Yeah, I kind of agree with that point. So yeah, that basically the more people understand it, the more people can inspect it, the safer it is, right? So yeah, I would say that probably the correct or the safer way for the zk is to start from something that has been understood and verified and like inspected by as many people as possible. So the digital signature is something that I mentioned. It sounds trivial, right, to everyone in blockchain space, but it is part of the zk, right? It is a zero knowledge proof. So those things they look basic because people, or they were not basic maybe 20 or 30 years ago, but after so many years of development and academic engineer development, it has been understood and well tested by like many people and many companies. So it becomes from the cutting edge to the kind of the norm, like the basic building block of the system. So that makes it like safe enough from like our perspective. I think the same thing might happen to zk. Like there are all those fancy stuff that people are talking about, but those might not be the best practice for an actual blockchain system to use until it's like more mature, more better tested, more like well studied.
Okay, that's a very interesting discussion. So I actually have a kind of more funny question. So do you think you would trust, like you are all kind of the leaders in your field, and you probably lead a team of developers and engineers. So from a normal people point of view, do you think you should trust like a DAO or decentralized autonomous organization more, or do you trust like we call it a benevolent dictator like Vitalik or Linus Torvalds more? So how do you balance these two? So what's your kind of personal opinion? This is not so technical, but I just want to throw in for some fun.
This is Dietrich. I really fall back to kind of what Raullen was talking about earlier around transparency. I think I would even only trust a decentralized organization in as much as I can validate and see what's going on. And so I guess to some extent that's a little bit of trustlessness. If you're able to verify, the kind of attack surface of delegated trust is smaller. And that I think is an interesting property in this whole space that kind of doesn't exist in the old world of how we were either doing business, creating organizations, or being part of a community online. So I think there's, with that delegated trust, the ability to delegate smaller and smaller amounts of trust in exchange for being able to validate and verify what is happening with any interaction online, whether it's financial or not, is really powerful and impactful. I think there's also times and places to trust to work with benevolent dictators, right? And that trust is often earned through a long period of time. And I think you see that a lot in very large or complex open source projects. So when you have a very large group of developers working together around a common end, really good leaders will emerge in those communities that set up best practices that kind of prove their trustworthiness around the decisions that they make and how they wield their power in a given community to be able to make sure that community can grow and stay healthy I think those are places where I've seen the benevolent dictator model serve to great effect, as evidenced by the kind of people that you referenced in the question itself.
Okay, thank you, Dietrich, for the additional kind of perspective. So back to the trust. So let's talk about kind of normal people who are on, like, for example, like me and the audience in this chat. So how can we make them like not sacrifice the convenience, but still have the trust? Because, for example, like we talk about Facebook, and we haven't had any Web3 version of Facebook yet. And because I think even though trust is important, but will people value trust more than convenience? And will people willing to pay for trust? I don't know if anyone wants to take on this question.
Yeah, I can. So I would say that, sadly, from my observation, people, like 99% of the people, won't sacrifice convenience for trust. Like those 1% of people, maybe half of them are like really different, or half of them are like victims of some of the attacks. So they actually realized how important the privacy or security is. But for the majority of people, yeah, I would say no. People, from my observation, people won't sacrifice convenience. So it's our responsibility as a developer to make those products, or to build a product that is as convenient as a Web2 or existing product, right? It takes time. It takes a long time, but that's something we have to do. But otherwise, most people will still choose the more convenient solution, probably.
Okay.
Yeah.
Go ahead.
Yeah, I completely agree with Elon's. Basically, so we collect a couple of data. So where only 4% of the users from the Web2 now enter the Web3, given the numbers of different exchanges and wallet numbers. So which means that there's still huge space to grow the Web3 users. But the major barrier is still the convenience. Like, for example, even setting up the wallet, I'm not sure everybody's the first experience, but my first experience of setting up the wallet, even I already set up the key store. Today I cannot even find it because I have no idea how to, for example, store this data professionally at that time. So there's still a pretty strong learning curve for users. And one thing that I think all of us should do is to how we're able to reduce the barrier, like back to Web2, like when people started without the graphics user interfaces, then people using all kinds of the text tools like Telenet, FTP, all kinds of things. But this is kind of like I would say the similar situation as Web3, like people still using like a lot of these wallets that you have to remember all this private key, all this memory, the key words. So that they should have something that we can do that to improve this user experience from the very beginning. And definitely, when there's a couple of other issues like scalability, like we still have high transaction fee. We still have, for example, very limited storage, and those are things we are still with the latest technology. We will gradually solving these problems. So from the user's perspective and then to the end-to-end infrastructure perspective, there's still a lot of space for us to improve. Yeah.
Okay, thanks, Chi. So, and also for listeners on the channel, please feel free to type your questions in the chat so we can collect them and then ask the panelists. And then I think we are getting closer to like our last 10 minutes or so, or 7 or 10 minutes. So maybe I'll ask more directed question to some of the panelists. So, for example, maybe for Chi, so you have been working on the Ethereum kind of core team. So now the big debate was proof of state and proof of work, and there's some forks coming up. So I don't think we want to go into that debate, but do you think there's some kind of technology that can improve trust on both tracks? And are they the same or are they different? Because they are so different in terms of the architecture? And do you have any kind of highlight or like a high-level overview about the kind of the security and trust improvement on both sides of the fence?
So actually, this is also a question that I've also asked Vitalik when he
Okay.
make decision to move from POW to POS. Even though we know we read a lot of basically documents and articles he wrote about POS benefits, but still, like I think a lot of people have concern because like proof of works is already battle tested. It has survived from several maybe shutdowns from for example in China and a lot of different areas. It still works pretty well due to the its permissionless features for mining. One direction I can think about is kind of like a new consensus that can combine POS and POW, but so that they can harvest a couple of benefits. The POS was given that is slashable, so that there's kind of like commitment of being honest operator, so that when something bad happens, then we can there's a slash. That is one major argument from Vitalik saying POS is more secure. At the same time, we still want to maintain kind of like permissionless feature as proof of work, because like in the proof of stake, even we want to switch from one, for example, to one validator as a delegator want to move my votes from one validator to another, still needs to go to the blockchain network, still needs to basically unlock my token and then redelegate all kinds of feature. But in the blockchain world, actually, as long as you hash power, no matter the network is basically processing the transaction or not, now you're still able to produce a block. So from that perspective, I feel proof of work has several advantages versus proof of stake. So it's possible to combine all their benefits. I think that really deserve kind of like experiment and exploration. Yeah.
Okay, thank you, Chi. Then we will switch maybe to IPFS related questions. So actually, Dietrich, in one of our chat applications, decentralized chat app, we also use IPFS to store large files. So we also know like a majority of NFT are stored on the IPFS. One question I have is how do you see? How can you kind of like? Do you think we need to ask people to pay for it? And how can we make this ecosystem more sustainable long term so the people who provide the storage and the running nodes and gateways will be compensated for providing all those valuable services?
Yeah, that's a fantastic question. And I'm excited to hear that you're storing large files on IPFS. If you ever have questions or want to talk about the challenges, I'd love to learn more about what your architecture looks like to do that. But to your question, I think one of the challenges that we have when communicating about IPFS is that people do think that there is some kind of magic in that other people are storing your files for you. And while that is true to some extent, the network itself does not replicate files to other people's computers. If you're running an IPFS node, your IPFS node will never store data for other people that you don't put there. And that is kind of removes a lot of the magical thinking about it. Now, there are very unique characteristics around content addressing and the benefits that P2P search and retrieval and distribution get you in that network. But at the end of the day, somebody else, you need to make sure that your files are stored persistently on someone's computer that is online all the time if you want those files to be available. This is really similar to the web today. Now, today, you would pay a web host of some kind, whether that's AWS or Azure or Dropbox or your own server, where you pay an internet service provider, you pay someone to be able to keep those files available all online all the time. IPFS is not different in that regard. If you want your files to be available all the time, you should pay somebody to make sure that that stays true. Where it's different is that with HTTP, you paying that person to keep your files online is the floor of availability of that data. With IPFS, or is the ceiling of availability, is the maximum amount of resilience you can get for the data. But with IPFS, that's just the floor. Anybody else can also host a copy. And that unbounded upside of availability is very, very unique to the protocol itself. But I think at a base level, yes, you should pay people for files that you want to keep online, whether that's you running your own node on a computer that stays permanently online, or somebody else that you are paying, like a pinning service provider.
Oh, thank you. Yeah, we are actually running our gateway as well. So maybe you can kind of follow up with how can Web3
totally
kind of improve trust in the communication, day-to-day communication.
Oh yeah, sure. I can talk about that. Yeah, so I think to move from Web 2 to Web 3 and make the communication more like private, we kind of have to do a few things, which exactly what we are doing in NKN. So the first thing we do is that we have to move from the Web 2 identity to the Web 3 identity, because Web 2 identity are like typically binded to your like physical or real world identity, which will leak information for sure. So for the communication, this is from moving IP address, which everyone in the world will know who you are, where you live, all those kind of things, to the Web3 identity, which is just a public key. So the public key not only preserves your like privacy by making you anonymous, but it also provide native encryption of the data you are communicating, right? Because it is already is a public key, and the first step to do encryption is to exchange those public key. And the second step after we move the identity to the Web3 space, and is that we need to make sure that all our communication are encrypted end to end, so that no one in the middle can actually read what you are communicating and know or change the content you are sending, right? And that can be easily done if both parties know each other's public key. And the third step is that we need to move the infrastructure from like the traditional server based or infrastructure service provider based to like more decentralized infrastructure, so that no one or no service provider knows who you are communicating with. Well, some people may not realize, but knowing who is talking to who is also like a data leaking. It's a leak of information. But by moving from the more like a client server model to a more decentralized model or like decentralized relayers, we can like hide or like hide those information a lot better, so that the relayers don't know who is talking to whom, and those so by doing all those kind of things, we kind of can make our communication more private by hiding who we are talking to, and what we are talking to, and only reveal the information when we want, not when some other people want. So that is what we can do in the Web3 space to make our communication safe.
Okay, thank you, Elon. And then let's go to the last panelist, Raullen. So how can Web3 help build more trust with the smart devices, the billions of smart devices surrounding us every day?
Yeah, thanks, Bruce. I'll keep it short. I think the key here is trying to reduce the cost for building up trust overall, right? So for example, if we can provide like a trusted, decentralized, transparent kind of middleware, which we call web stream, is off-chain compute for those streaming data, I think this will help a lot of companies who's building something like a Helium, kind of MachineFi networks, basically to reduce the cost for them to build, also to reduce the cost for them to actually build up trust for their investors, for their users, for their developers as well. So that's why we're working on this, and I do think this is pretty interesting, also important. If you look at like for example, there are lot of step in, right, like a walk to earn type of projects. It's good in terms of like it's kind of very gamified, but it is not as transparent as other kind of projects. So you don't know actually everything's running on top of a central server. You don't know what they're doing inside. So as an investor, do you want to put in money into Stepan, right? Or in the long run, I mean, or Helium. Helium does a better job, but Helium you need top talents working on this for multiple years to building everything like from blockchain to the compute proof of coverage all the way to the application mobile apps. So that costs you a lot of time and energy to go to the market, right? So if we can consolidate all the effort in the middle, give them trust, give them transparency, give them efficiency, I think that's kind of like my answer to your question.
Okay, thank you, Raullen. So we are slightly running out of time, so we'll wrap it up today. And thank all the panelists for joining today, and also thank all the listeners. And I saw there's one question in the chat, when Web3 will become real. So actually, that's actually a great segue to announcement. So the second panel of the Web 3.0 Tech Talk will be 2 weeks from now. So it'll be September 23rd, also Friday, the same time. So the panel 2 are coming. We'll send some announcement later on. And so that's a wrap up. And thank you, everyone. And so if your friends missed the talk, it will be online for 30 days. And we also try to put it on YouTube as well. So thank you, Raullen, Dietrich, Elon, and Chi. And thank you, everybody listening today.
Thanks for having me.
Thank you for hosting.
Okay. Thanks.
Thanks. Bye-bye.